We introduced a physics-informed tropical cyclone tracking framework trophy that utilizes tools from vector field topology. We demonstrated that a trophy can capture tropical cyclones' characteristics that are comparable to, and sometimes even better than, a well-validated tropical cyclone tracking algorithm, while requiring far less input data.
We aim to make writing and ornaments on ancient tightly packed documents accessible. As the documents are too brittle to unfold them physically without damaging them, the need of digital methods of unfolding arises. We present an algorithm of creating a 2D manifold representing the thin layer structure of the substrate. Our approach allows boundaries, guarantees the construction of an orientable 2D manifold, and is more robust than other current methods.
With the growing size of unstructured machines, we need efficient data structures. Classic dynamic data structures compute connect information on demand, and discard them when no longer needed. However, such on-the-fly computation slows down the algorithm execution. In our appropriate approach, we separate the computational relations from the algorithm execution to improve the time performance. That is, we have another thread that will pre-compute for the thread that executes the topological algorithms.
Tensor fields have many applications in science, engineering, and medicine. Tensor field topology highlights features in the field. However, these topological features do not live in isolation. Instead, there are intricate relationships among them that can provide additional physical insight. In this paper, we introduce a graph representation for all topological features in the field and their interactions. Please come to our talk. Orbifolds are a modern mathematical concept with applications in tensor field visualization, meshing, and texture synthesis. Most orbifolds live in non-Euclidean spaces. In this paper, we introduce a mirror-based visual metaphor for the visualization of kaleidoscopic orbifolds in spherical and hyperbolic spaces. We also provide an algorithm to generate arbitrary polygonal kaleidoscopic orbifolds. Please come to our talk for details. Thank you.
We introduced TopSZ, an error-bounded lossy compression method that preserves the topological features in 2D and 3D scalar fields. The main idea is to derive topological constraints from contour tree-induced segmentations from the data domain and incorporate such constraints iteratively with a customized error-controlled quantization strategy.